All right. So here's a rapid overview of function notation and composite functions. When I start on page 60, I'm looking to look at the tables and go from the tables to get an answer. So for number 16, the first thing I look at is a G. That means I'm going to use this second chart. I'm going to go to 7. 7 points to -4. So I'm going to get f of -4. Okay, the -4 only replaces that G portion, which means I'm still left with f of. My f of goes to this chart because this one has the f of x. So I'm going to go to x is -4, which is right here, and it points to -9. And I go through so on and so forth. So let me do one in the opposite direction. Okay. So here on number 19, I have f of -2. F of -2 means I'm going to use my first chart, the purple chart. I'm going to go to -2, and I'm going to point over to -5. So this now becomes G of -5. I'm now going to go use my green chart, my second chart, because that's my G chart. I'm going to go to x is -5, and it points to 2. Okay. So that's going from a chart with our composites. Then we do it with graphs. Okay, so you can see I have a couple of writings on here from earlier today. Let's do a couple of examples. So let's go start on 29. 29, f of, so that's going to be my purple, 0. So if I'm starting on 0, I'm now looking for where it touches my graph, and that's an up and down movement. Okay, I move up 1, 2, 3, 4. This becomes G of 4. Now I'm going to go and use my green graph, which they've drawn red, but let's just go over it. Okay, I'm going to go use my green graph, and I'm going to go to 4. 1, 2, 3, 4. I'm going to go point downwards. Since I'm pointing downwards, it's going to be a negative, and I went down 1. So it's -1 is my answer. Let's do that again. Okay, so go erase all of my work. I'm going to start on 30. I'm going to go for G of -3. So I'm going to use my G graph. I go to -3. 1, 2, 3. Keep in mind we're doing x's right now. The x's cause us to look for y's, so I go downwards, so this is going to be a negative. And I go downwards 1, 2, 3. Then I'm going to use my f of -3. So I'm going to go 1, 2, 3, and go up 1. Okay, so that's on my graph. Those are my 2 examples of we're going to find what graph we're going to use first. So here we're going to use the green graph first. We're going to use the G graph. We're going to go to -4, which is here. We're going to count downwards 3, so that gives me a -3. This whole piece is gone now, but the f is still there. F, I'm going to go to -3, and I get my answer is 1. Okay. So let's do one more. If I start at f of -3, I've already gone and done this a couple of times, so it's going to feel familiar. I'm going to go to my F graph. I'm going to go 1, 2, 3. I go up 1 to get to my graph. So I get 1 as my answer. Then I go plug in G of 1. So now I'm going to G, I'm going to 1. G of 1 is located at -1. That's my answer. So that's your help going from a graph to another graph in composite functions. It tells you to do the inside one first, then go and use that answer you got to get your outside one. Okay? So in class, we did a bunch of these. We did a bunch of the whole, I give you a bunch of problems, and then you go and evaluate. Then I made you do the ones where it's all weird and wonky, and you plug in big numbers. Then I assigned page 65 as homework. So, page 65, I have f of g of x. G of x is this one. I'm going to replace g of x. Instead of writing g of x, I now write 3x. F of 3x. So now I need to go and I need to use my f equation. My f equation is 2x minus 1. I made a mistake here because I kept an x, and really I should be plugging into that. And when I plug into that, I plug in anything that was in right here. 3x. So now I distribute. I get 2 times 3 is 6x minus 1. Dunzo, can't do anything more with that. That's my answer. Okay. H of x. For h of x, I'm going to use this equation. So instead, I'm going to write x squared plus 1 and I'm going into f. So I'm going to use my f equation. My f equation is that 2x, we're going to put parentheses there, minus 1. So I plug in this red piece where my x was. So now I'm going to distribute, and I get 2x squared plus 2 minus 1. 2x squared plus 1. Final answer. Done. Okay. Then you're going through and you have ones where you evaluate. Okay. So there's a couple of ways you can do this. You can do it by plugging in the number that we had done before. So like I'm going to use my h equation. So I'm going to go h of 7 equals 7 squared plus 1. This becomes 49 plus 1. That becomes 50. Then I can go and plug that 50 in for my f equation. This gives me 2 times 50 minus 1. 2 times 50 is 100. Minus 1 gives me 99. Okay. Option 2 is, do you see how this was a red box on the inside and a red box on the inside? A purple box on the outside, a purple box on the outside. So I can use this equation that I got and try it out. Let's use a different color. Blue. So I have 2x is my 7 squared plus 1. 7 squared is 49. 49 times 2 is going to give me 98. plus 1, 99. Either method is valid. If I had a ton of problems that I listed that looked like the red box and the purple outside, I would want to use this equation over and over and over again. But some of you like doing the problem twice. So here's your first step, your second step of the problem. Your choice, either one. Okay. 27, I think, is the gruesome one. 27, I'm going to use my purple equation, my f of x. I'm going to replace it into that g of x. So this means I'm going to get something squared plus something. Wow, very exciting. This is 9 minus x. This is 9 minus x. What's really gross about this is that this causes you to do binomial multiplication. So if I rewrite this as 9 minus x times 9 minus x, this is the same thing as when we do our box method. 9 minus x, 9 minus x. 9 times 9 is 81. 9 times negative x is negative 9x. 9 times negative x is negative 9x. That was off your screen. Sorry, guys. X times x is x squared. It was a negative times a negative, which makes a positive. So this gives me x squared minus 18x, because those add together, plus 81. These are your polynomial rules. These are things that you should know how to do. Some of you might have been taught FOIL, the first times the first, the outsides times the outsides, the insides times the insides, the last times the last. Some of you may have just been taught double distribution, so you distribute one rainbow and then you distribute the other rainbow. Then I add my like terms together. X squared is by itself. 18x and regular x make negative 19x. And then 81 plus 9 makes 90. Done. That's my answer. Okay? Gruesome, really difficult, really hard. Again, you'll notice that this is a purple box with a green outside. You can use this formula if you want to answer that question, or you can do the two-step process. Your choice. I'm going to pause there for homework help. That's the end of that video.